So, hello, a very good evening to all. I am audible. Hello, yeah, good. So, I'm just launching a quick poll here, ठीक है? सभी लोग फटाफट इसका रिप्लाई करो, राइट? चलो, good. So basically in today class, what we are going to see chemical kinetics, right? So we are going to see the chemical kinetics and try to solve much more numericals on this chapter, that is chemical kinetics. Okay. So this is going to be a very interesting session for all of you, in which we are doing lots of question practice from JEE NEET questions, chemical kinetic chapter. Okay. Chalo. So let's start with the class. Let's start with the class, right? Okay. So, so basically in chemical kinetics, first of all, in starting 10 minutes, we are going to see all the important formula related to this chapter, right? And in later part, we are going to see the questions. Okay. Just tell me once, my screen is visible. Just, well, yes. Chalo, fine. Okay. So we all know how will you represent the chemical reaction, right? Because if we have any reaction, we have a two parts, right? Reactant and product, right? So let's see how will you write the rate of appearance and rate of disappearance. So basically, the rate of disappearance of reactant means how the reactant consuming and formation of product will takes place, right? So rate of reaction is basically defined as the decrease in concentration of the reactant divided by the time taken, right? So this is how will you actually represent the rate of reaction. Let us assume if R1 is the concentration of the reactant at T is equal to 1 means time 1, T is equal to 1 time per, and R2 is the concentration of the reactant at particular time T2. Now how will you write the rate of disappearance? So the rate of disappearance is basically we can write as delta R divided by delta T. And this negative sign indicate that there is a decrease in the concentration of the reactant. So whenever you need to write the disappearance, rate of disappearance, always use this negative sign. That is minus delta R by delta T. So this is how you can actually represent the rate of disappearance of reactant. On the similar note, if you want to represent the rate of appearance of product, so how will you write beta? That is rate of reaction, basically increase in the concentration of the product divided by the time taken. So you can just write as delta P by delta T, and here we are using positive sign. So is this clear to everyone? Rate of disappearance, negative sign. Rate of appearance, we are using positive sign. Is this clear to everyone? Just tell me. Yeah, chalo, good. Right. Now, what are the factors which affect the rate of reaction, right? What are the factors which basically affect the rate of reaction? So we know there are basically four factors. There are many factors which affect the rate of reaction, but mainly we divided this factor into a four types, right? The first one is, that is nature of the reactant. So nature of the reactant is highly influence the rate of reaction, right? Now the second is, that is concentration of the reactant, right? So this is also a very important factor which influence the rate of reaction. And the third is nothing but temperature. So temperature also affect the rate of reaction. And the last but not the least, that is the catalyst, right? So these four factors influence the rate of reaction in a very fast way, right? Like nature of the reactant, concentration of the reactant, temperature and the catalyst. ठीक है? चलो, तो मैं अभी ये ना जल्दी जल्दी से बस रिवाइज करा रहा हूँ बिकॉज मेनली वी आई वांट टू सॉल्व न्यूमेरिकल्स, राइट? सो वी जस्ट गो थ्रू, एक बार रिवाइज कर रहे हैं ताकि हम लोग फटाफट क्वेश्चंस को सॉल्व कर सकें, ठीक है? सो इट्स अ क्विक रिवीजन टाइप, ठीक है? चलो, नाउ व्हाट इज द रेट लॉ? सो एवरीवन नो कि रेट लॉ को हम किस तरीके से लिखते हैं. That is whenever we have a certain reaction like AA plus BB, that is the reactant side, react together to form product, that is CC and DD, where small a, small b, small c, small d are the stoichiometry coefficient. So will you write rate is equal to, according to the rate law, rate of the reaction is equal to concentration of the reactant, right? And their product raised to the power alpha and beta. This alpha and beta is also known as order of the reaction. So किस तरीके से हम लोग लिखते हैं rate law? So this is the rate law. Very important to understand. ये formula हो गया किसका? Rate law का. That is R is equal to K, concentration of A raised to the power alpha, concentration of B raised to the power beta. And this alpha plus beta is equal to n, also known as order of the reaction. So remember this thing better, okay? So this is the rate law expression. Now, types of reaction based on the number of step, right? For example, the reaction which is takes place in a one step is known as elementary reaction. Similarly, the reaction which is takes place in more than one step is known as complex reaction. So this is very important to understand. The reaction that occur in a single step are called elementary reaction. For example, the decomposition of H2O2. So H2O2 easily decompose into H2O plus half O2. Similar, ammonium NO2, it decompose into N2 plus 2H2O. So these all are the example of elementary reaction which takes place in one step only. Now, move to the complex reaction. So in a chemical reaction, a sequence of elementary reaction takes. Such reaction is called complex reaction. It means complex reaction consists of lots of elementary reaction, right? It means two elementary reaction combined together to form one complex reaction. Simply, we can define in complex reaction more than one step is present, right? So in a complex reaction, the slowest step of the elementary reaction is known as rate determining step. This is very important. RDS. So if someone asks if we have a two-step reaction, then which step actually represent the rate determining step? So always remember, beta, that is the slowest step. Slowest step is the rate determining step. Always remember. Let's understand through this example. For example, if we have this kind of reaction like 2NO react with 2H2 to form N2 plus 2H2. So here this reaction will take place in a two step. The first step is slow and the second step is the fast step. So if someone asks which step is the rate determining step, कौन सा होगा बताओ जल्दी फटाफट. Which step is the rate determining step? That is the slowest step. That is the first step. So step number one is the rate determining step. ठीक है? And the rate of reaction depends upon only the rate determining step. So we can write as R is equal to K rate constant, NO raised to the power 2, H2 raised to the power 1. So this is how we can represent the rate of reaction. Is this clear to everyone? That is, in case of complex reactions, slowest step is the rate determining step. Yes, please confirm beta once. Is this clear to everyone? Right? Yes, good, good, good. चलो, now मैं थोड़ा सा फास्ट फास्ट इसलिए करा रहा हूँ बिकॉज ये चीज ऑलरेडी तुम पढ़ चुके हो, राइट? हमें क्वेश्चन सॉल्व करना है, वी आर गोइंग टू सॉल्व द क्वेश्चन विच आर द मेन, जो हमारा वर्क है आज का वो क्वेश्चन सॉल्व करना है, तो इसीलिए इसको थोड़ा सा हम जल्दी जल्दी कर रहे हैं, राइट? बिकॉज दिस थिंग यू ऑलरेडी स्टडीड. चलो, नाउ we have integrated rate equation for the zero order and the first order, right? So let's see the integrated rate equation for the zero order. So basically you need to remember this formula only for the zero order. Like sometime it also written as k is equal to r naught minus r divided by t. So this is the integrated rate equation for the zero order, right? So someone represent the concentration by r, some represent by c. So it's the same thing. Either it will written as a C naught minus CT or R naught minus R. Both are same. And K is the rate constant and T is the time, right? How will you draw the graph basically? So we know the equation for the straight line, right? Y is equal to mx plus c. So this y in a y-axis, x belong to the x-axis and m represent the slope. And c is what? C is the intercept, right? So on the basis of this equation, straight line equation, we can easily plot a graph for the zero order equation. Okay. So what you need to remember? First, you need to remember this formula for the zero order. That is R naught minus R divided by T. So this formula we are using only for the zero order. Always remember better. Okay. Now let's see the graph, right? Graphical representation. So let's see the graphical representation. So for the zero order, graph is like this. Okay. Here we have CT, someone also written as R naught. So R naught or CT both are same. And this is T. So this is the slope. What is the slope of this curve? Can anyone tell me? What is the slope of this curve? That is minus. ठीक है, कितना आएगा? माइनस के. Okay, so we can write as slope is equal to minus k because this slope is in decreasing order. So we can say that slope is equal to minus k. So for the zero order, we get the graph like this, right? In y-axis, we have a r naught or ct. In x-axis, we have a t. And slope is equal to minus k. ठीक है? So this is the graph and the equation. Now let's see for the first order. So this formula you need to remember for the first order. This is very, very important formula. Someone also write as K is equal to 2.303 divided by T, and this is log R naught by R. What is R beta? So R is the concentration, initial concentration of the reactant, and R is the concentration at a particular time T, right? So we can write the formula for the first order, that is 2.303 divided by T log R naught by R. Okay. Now let's see the graphical representation. So let's see the graphical representation for the first order as well. So same on the same basis, just like the zero order. If we plot the graph for the first order, we also get the same graph. Just different क्या है यहाँ पे? Where we have only CR or we say R naught, but here we have a LNR, right? So we can say that LNR or we can write as LNR or LNCR. Both are same thing, right? So this is the graph we get. So similar to the zero order. बस difference क्या है? वहां पे y axis पे क्या था? Only we have R, but here we have a LNR. So this is the difference. Rest all the things are almost same, right? We getting the same kind of graph where slope is equal to minus k. So this is the graph for the zero order and the first order. So this is for the first order. This is clear to everyone? Chalo. Now, let's see the half-life for the zero order reaction. So, half-life for the zero order reaction is equal to T half is equal to C naught by 2K. Also written as T half is equal to R naught by 2K. So, this is the formula for the half-life time for the zero order. Similar, from this expression, we can say that is half-life time is proportional to the initial concentration of the reactant. So, if someone asks, whether half lifetime depend upon the concentration or not in the zero order and first order. So you can say that in case of zero order, half lifetime is directly proportional to the initial concentration. Whereas in first order, we are going to see this as well, where in the first order, half lifetime is independent of the concentration of the reactant. Okay? So this thing is very, very important. So T half, we can say that it is directly proportional to the initial concentration and is inversely proportional to the rate constant as well. ठीक है? तो हाफ लाइफ ऑफ अ जीरो ऑर्डर रिएक्शन जैसे तो ये इसका फॉर्मूला हो जाएगा हाफ लाइफ ऑफ अ जीरो ऑर्डर रिएक्शन. ठीक है, चलो. So this is the graphical representation of the half life of the zero order, right? Now, for the first order, half lifetime comes out to be, that is, we just substitute the value. So we get the formula like T half is equal to 0.693 upon K. This expression you only need to remember, right? Because we already know this formula, right? For the first order, K is equal to 2.303 upon log R naught by R. Just we are putting the values. For example, the how it is half lifetime. So basically half lifetime is the time in which the reactant reduce half of its initial value. यानी एक ऐसा टाइम होता है जिसमें रिएक्टेंट कितना रिड्यूस हो जाता है, half of its initial value. So this is called the half lifetime. So just put the value, we put Cr is equal to C naught by 2 and T is equal to T half by 2. On putting this value, you'll get T half is equal to 0.693 upon K. So in this expression, observe very carefully, half lifetime for the first order is independent of the initial concentration of the reactant. It does not depend upon the initial concentration of the reactant. Now, ठीक है. So this is the formula we'll get basically कि T half is equal to 0.693 upon K. So this formula you need to remember. Okay, where 0.693 is the values and K is a constant. That is the rate constant you need to remember. Chalo. Now, last, we are going to see the Arrhenius equation, right? So basically, Arrhenius equation describe the temperature dependency of the rate of reaction, that how the rate of reaction depends upon the temperature. So basically, it is observed that with the rise in 10 degree of temperature, the rate of reaction become almost double. So for every rise in 10 degree of temperature, rate of reaction become double. For example, if at temperature 290 Kelvin, if the rate of reaction is R, right? Then at 300 Kelvin, the rate of reaction become 2R. At 310, they become 3R. So every 10-degree rise in temperature, the rate of reaction become almost double. ठीक है, चलो. So let's see the Arrhenius equation. So Arrhenius give this equation k is equal to a exponential minus Ea by RT, where k is what? That is the rate constant. What is Ea? That is activation energy. What is R? That is a gas constant, which value is 8.314. T is the temperature. And A is nothing but the Arrhenius factors, also known as frequency factor. So this equation is very, very important to understand, that is k is equal to ae minus ea by rt. So this is the expression for the Arrhenius equation. Is this clear to everyone? Chalo. So a is known as Arrhenius factor, frequency factor, or sometimes pre-exponential factor. Right? Now, let's see the graphical representation of Arrhenius equation. So we represent the Arrhenius equation by this graph as well, in which in y-axis we are taking log base k, and in x-axis we are taking 1 by t. So slope, what is slope we will get? So slope is minus Ea by R. तो slope क्या मिल गया हम लोगों को? Minus Ea by R. So Ea is equal to माइनस आर स्लोप. ठीक है, तो एक्टिवेशन एनर्जी का फॉर्मूला क्या हो जाएगा? जस्ट मल्टीप्लाई बाय स्लोप इनटू माइनस आर विल गेट द एक्टिवेशन एनर्जी. ठीक है, so let's see the important formula for this. So this formula we basically derive at a two different temperature for the Arrhenius equation. That is log K2 by K1 is equal to Ea upon 2.303 R into T2 minus T1 divided by into T2 minus T1 divided by T1 into T2. So this formula is very important to understand. for the Arrhenius equation. ठीक है, चलो. Now we are going to see some questions based on these formulas like rate law, first order, order molecularity, complex and elementary reaction, and Arrhenius equation. So now we are going to solve some questions, right? So this question ये कब आया है? नीट 2024 के में ही आया हुआ है, अभी फिलहाल में जो पेपर हुआ था. So what the question asks basically? So just read this question carefully. So they are saying following data is for the reaction between A and B observed, right? Concentration of A and B are given. Rate reaction is also given. What is the order of reaction with respect to A and B? Right. So they are asking what is the order of reaction. So basically, how we write the rate law. We write the rate law like K, concentration of A or X. This is how we actually write the rate law, right? Now, in this, we need to find the value of X and Y, right? So let's see how will you find the value of X and Y in this expression. So, फटाफट देखो. So we have a three equation. Equation number one, equation number two, and this is nothing but equation number three, right? So let's see equation 1 and 2. So equation 1 and 2. So how will you write beta? So for equation 1, rate is given, right? That is 2 into 10 ki power minus 3 is equal to K, and the concentration of A is 0.1 raised to the power X, and concentration of B 0.1 raised to the power Y. Similar for equation 2, it is given, right? It is given, that is 4 into 10 raised to the power minus 3, and this is equal to K, and here what is, here we have a value 0.2 raised to the power X and 0.1 raised to the power Y. Just divide these two equations, right? So divide equation 2 divide by equation 1. What you will get beta? That is 4 into 10 ki power minus 3 divided by 2 into 10 ki power minus 3 is equal to K get cancelled, and this will become 0.2, 0.1 raised to the power x, and this 0.1 get cancel. ठीक है, ये क्या हो गया, कैंसिल. ओके, जेएनवी नॉर्थ एंड मिडिल ने क्या बताया है? सी. ठीक है, और सर ने बोला है आपका सी. ओके, सो वी आर गोइंग टू सी द सॉल्यूशन बेटा एज वेल. ओके, देखते हैं सी आ रहा है कि नहीं. एंड दिस विल गेट कैंसिल. सो 10 raised to power 10 raised to power 3 get cancel, and 2 2 is 4, so here we get 2. एंड यहाँ पे कितना आ गया जल्दी बताओ. तो यहाँ पे आ गया हम लोग का 0.2 और 0.1, यानी ये कितना आ गया, 2 आ गया रेज टू द पावर एक्स. यानी ऑब्वियसली हेयर वी हैव व्हाट इज द वैल्यू, दैट इज 1. सो x कम्स आउट टू बी 1. So this is very much correct. X कितना आ गया है, 1. Now what is y? If x is equal to 1, then what is y beta? We'll just put the value, we'll get the y. For example, here we have a r is equal to 2 into 10 ki power minus 3 in first equation. What is k? ठीक है. So just like we are taking equation 1 and 2, in second case, which equation you are going to take beta? You are going to take equation, which equation? You can take either, like you will take equation 2 and equation 3 as well, right? Equation 2 and equation to 10 की power minus 2 on dividing. What you will get minus 3 is equal to 0.2 की power y, right? Because 0.2 divided by 0.1 is always 0.2 only. Right. Okay. So what you will get, beta? 10 raised to the power 2, 10 raised to the power 2 get cancelled. So this is become 4 for the 16, right? So this will become 4 and this will become 2 raised to the power y. So this will become 2 raised to the power 2 and 2 raised to the power y. So y values comes out to be 2, right? So y की वैल्यू कितनी आ गई है? 2. Very good. So option C is absolutely correct. So सबने सही बताया था. That's a wonderful कि x भी हमारा कितना आया? x आया 1 and y आया 2. So I hope this is clear to everyone, right? चलो. Now, move to the next question, beta. Next question देखो क्या है. So what they are asking basically, they are saying the rate constant, yes, the rate constant of a reaction at 500 Kelvin and 700 Kelvin are given. Then what is the activation energy? So can anyone tell me which formula we are going to use? Basically, we are going to use the activation energy formula, right? So what we'll get the formula, that is log K2 by K1 is equal to EA upon 2.303 R, right? And here we have T2 minus T1 divided by T2 into T1. So this formula basically we are going to use Arrhenius equation, right? Good. So log K2 by K1 is equal to EA upon 2.303 R T2 minus T1 divided by T2 into T2. Now, what is K2 and K1? So K2 is 500 Kelvin, we have a K1 this, and T2 700 Kelvin, we have a this. So K2 is basically 0.14 and K1 is equal to 0.04. This is EA we have, and this is 2.303. R values is given 8.31. And यहाँ पे subtract करो, that is 700 minus 500 divided by 700 into 500. So this is what we get. So just solve this value better. So what is the value of log 0.14 and log 0.4 comes out to be? So let's solve this. So this value comes out to be log, and we can write as log 14 divided by log 4, right? So we can write as log 14 divided by log 4. So this actually comes out to be log 3.5, right? And in this question, log 3 point value is given. Okay, log 3.5 values is already given. So this is log 3.5. This is EA on solving 2.303 into 8.1. 8.31. What's the value? Almost 19.1. Remember this value, right? 8.31 and 2.3031. And this is 700 minus 500 comes out to be 200. So this is 200 and this is 1, 2, 3, 4. 2020 get cancelled, right? So and log 3.5 values is given 0.54. Just write me. ठीक है. ठीक है. So just write it. That is 0.5441, right? Into 19.1 into 3500 and divided by 2. So on solving, you'll get the value of EA. So EA comes out to be 18219. 18219. On solving, you'll get this value. 18219. So which is the correct? That is C. So option C is absolutely correct. 18219 Joule. So this is the correct answer. Yes, beta. Good. Now, let's see the next question. Activation energy of any chemical reaction can be calculated if one knows the value of what? So how will you calculate the activation energy of any chemical reaction if we know what, beta? Out of option A, B, C, D. Tell me the answers. फटाफट बताओ क्या होगा. JNV चित्रदुर्गा डी. डी बोला है एक बच्चे ने, एक ने ए बोला है, एक ने फिर से डी बोला है। गुड। जेएनबी चिकाबालापुर ने भी डी बोला है। ठीक है, देखो बेटा, लेट्स सी द करेक्ट ऑप्शन। They are asking activation energy of any chemical reaction can be calculated. How? If we know the rate constant at two different temperatures, obviously it's a very simple question, na? The first option states that the rate constant at the standard temperature, not standard temperature, beta. Rate constant at a two different temperature, right? Because we are using the formula. Just now we are solving question in this particular formula, that is log K2 by K1 is equal to EA upon 2.303 R into T2 minus T1. So if we have two different rate constant value at a two different temperature, then we can easily calculate the activation energy, right? So the rate constant at a two different temperature, we can easily calculate the activation energy. So option D is absolutely correct, not option A. ठीक है, चलो, this is also very important. The rate of a reaction become quadruples when the temperature changes from 27 degrees Celsius to 57 degrees Celsius. Calculate the energy of activation. So just calculate, beta, everyone. The rate of reaction become quadruples. What do you mean by this thing, quadruples? When the temperature changes from this to this. So you need to calculate the value. ठीक है? So in this basically, which formula you are going to use? Yes. So at T is equal to 1, है ना? यानी जब टेम्परेचर 1 है, T1 मानो 27 है ना, तो इट विल 300 कैलोरी। ठीक है, एंड T2 क्या है? दैट इज 57। सो 273 और 57 ऐड करो, तो 7 3 10 3 and this is 3 3 330। दिस विल बिकम 330 कैलोरी। ठीक है, 330 Kelvin. So at 300 Kelvin, let us assume if K1 is equal to K. So the reaction become quadruples, means four times. So at 330, K2 become 4K. So this is what they are asking basically. Okay? So this statement you need to write. At T1 300 Kelvin, the rate constant is K, and at 330 Kelvin, the rate constant become four times of K, yani 4K. So just put the value, that is log K2 by K1 is equal to EA divided by 2.303 R, and this is comes out to be how, sir? Beta, basically in this question they are saying the rate of reaction quadruples, means when the temperature changes from 300 Kelvin to 330 Kelvin, the rate constant become quadruples. Quadruples means four times, right? So you in this question you need to assume na if at 300 Kelvin, if the rate constant is K, then at 330 Kelvin, the rate of reaction becomes 4K, because this is स्टेट इन दिस क्वेश्चन कि रेट ऑफ रिएक्शन कितना टाइम्स बढ़ रहा है, फोर टाइम्स इंक्रीज हो रहा है, राइट? सो फोर टाइम्स मींस दिस इज दिस क्लियर नाउ? यस, टेल मी, नाउ इज दिस क्लियर? ओके, सो log k2 and k1, ठीक है? सो log k2 is what? So log k2 here we have 4k, ठीक है? log k2 here we have 4k, so 4k divided by k. Here ea we have ea, this is 2.303 and r is 8.314, and this is 330 minus 300 multiply by 330 into 300. So this is what you will get. So log 4 values is already given in this question, 0.6021. This is EA. On solving, you'll get 19.1, and this is 30, and when you multiply 330 into 300, what you will get, beta? 330 multiply by 300. So when you multiply 330 into 300, you'll get the value, right? इसको solve कर लेना तुम लोग, simple है. 330 into 300. That is 330 into 300. It comes out to be 99,000, right? 99. Calculate EA. So on solving, what is EA comes out to be? EA comes out to be 387, right? We can write as so 38.07. 38.7 kilojoule per mole. So which option is nearly to this calculation? That is option number A. So option A is absolutely correct. क्वेश्चन ने बताया भी था आई गेस कि ऑप्शन ए ही होगा. ठीक है. यस, जेएनबी कुरनूल ने बताया था एंड एम कौशल जेएनबी चिकाबलापुरा ने भी बताया था. गुड. सो 38.04 इज द करेक्ट आंसर. इज दिस क्लियर टू एवरीवन? सबको समझ आया? चलो, नाउ लेट्स सी द नेक्स्ट क्वेश्चन. फॉर द रिएक्शन 3A gives us 2B. Right? So for the reaction 3A gives us 2B. The average rate appearance of B is given by delta B by the correct relationship between the of A in a given option. ठीक है? So they are saying कि for the reaction 3A gives us B. Right? Chalo. So in this, you just need to write the relationship between rate of disappearance and rate of appearance, right? I, the rate of disappearance 3 del A by del T. Hmm. Similarly, rate of appearance delta B by delta T. So, what is the relationship between these two? So, the correct relationship of the average rate of appearance B with the average rate of appearance of A. So, we can write as 1 by 2 del B by del T is equal to minus 1 by 3. Hmm? So del B by del T comes out to be minus 2 by 3 del A by del T. ठीक है? So this is the del A by del T, which is comes out to be minus 2 by 3 of del A by dt. So which option is correct, beta? Yes, C, C, C. वेरी गुड. तो सबने ही सही बोला है, तो इट्स अ ग्रेट बेटा. ठीक है, सबने सही आंसर बोला है. वेरी गुड. सो सी इज द एब्सोल्युटली करेक्ट आंसर. ठीक है, तो सी हमारा क्या हो गया है यहाँ पे? करेक्ट आंसर हो गया. गुड बेटा. गुड एवरीवन. चलो, इसको बताओ फटाफट. द करेक्ट ऑप्शन फॉर द रेट लॉ correspond to the overall first order reaction. For the first order reaction, which is the correct option? Yes, it's a very simple question. B. No, beta. In B, we have no values now. So this is 1 and 1. So this will become 2, not the first. They are asking the correct option for the rate law corresponding to the overall first order reaction. जिसका overall अगर आप करो x plus y is equal to n होता है ना, तो x plus y को अगर आप solve करो तो you'll get the value 1. So out of this fourth option, in which you'll get the first order. Yes. D option. Hmm. Obviously better. Because in D option, we have x is equal to minus 1 by 2 and y is equal to 3 by 2. So minus 1 by 2 and 3 by 2 on solving you'll get what? 1.5 में से आ जाएगा कितना? 1. सो दिस इज द करेक्ट वन, ठीक है। तो क्या आ जाएगा आपका? ऑप्शन डी इज एब्सोल्युटली करेक्ट। क्लियर है? हाँ, चलो गुड। सो डी इज द एब्सोल्युटली करेक्ट आंसर। नेक्स्ट देखो। फॉर द सर्टन रिएक्शन द रेट इज इक्वल टू K A raised to the power 2 and B. When the initial concentration of A is triple, keeping concentration of B constant, the initial rate would be. Initial rate यहाँ पे क्या होगा? Okay, beta. I'm trying to increase the font size. I think it's already in maximum, right? Chalo. So for the certain reaction, the rate is equal to Ka raised to the power 2 and B. Now, when the initial concentration of A, B बोला है बच्चों ने, A is triple, keeping concentration of B constant, what is the increase by a factor? ठीक है. So first of all, we have a R. So R is equal to K A raised to the power 2 and this is B. Okay. So this is equation 1. Now let's see the next thing. R1 become, they are saying when the initial concentration A is triple. A को triple कर दो. So this is become triple 3A. Keeping B constant. B को same रखो. कितना आएगा ये? 3 का स्क्वायर 9 हो गया. So this is 9K. A का 2 रहा. B का B रहा. This is equation number 2. Now just compare. So we can say that R dash is 9R. बोल सकते हैं R dash is equal to 9 times of R. यानी they are increased by the factor of 9. तो D ऑप्शन करेक्ट होना नहीं, increase by the factor of 9. B होना चाहिए बेटा करेक्ट, ठीक है। तो B इज द करेक्ट ऑप्शन। कुछ बच्चों ने D भी बोला है। D नहीं बेटा, B ना। देखो, इट इज इंक्रीज बाय द फैक्टर ऑफ 9। तो फैक्टर 9 के फैक्टर से ये क्या हो गया है? इंक्रीज हो गया है। so this is increased by the factor of 9, so B is the correct option. Is this clear to everyone? Done? Yes. चल, नेक्स्ट देखो। नेक्स्ट देखो। so for the chemical reaction 4A plus 3B gives us 6C plus 9D, right? So for a chemical reaction 4A plus 3B, this gives us 6C plus 90. The rate of formation of C is 4 into 10 raised to the power minus 2 mole per liter second inverse. And the rate of disappearance of A is also given. What is the rate of reaction and the amount of B consumed in the interval of 10 seconds respectively? जाएगा. Then we are going to calculate the amount of, ठीक है? And this is also equal to, some network issues are there right now. Are you able to see the screen? Just confirm me once. Hmm? Done? Yes, sir. Good. Chalo. So we can write rate of friction is equal to minus 1 by 4 dA by dt, also equal to minus 1 by 3 dV by dt, and also is equal to 1 plus 1 by 6 plus dC by dt. So we can write in any manner, right? So let's calculate the value. So here we have a minus 1 by 4. And what is dA by dt? So value of dA by dt is given na. The rate of disappearance of A is this, that is 4 into 10 की power minus 2. So 4 get cancelled. So rate of reaction become 10 raised to the power minus 2. ठीक है. So 10 raised to the power minus 2 is the correct rate of reaction. So this is the 10 raised to the power minus. ये तो क्या आ गया, rate of reaction. You can use either we are using rate of disappearance terms. You are also calculate by using the rate of appearance, right? So this is very simple. Now, तो rate of reaction आ गया है, that is 10 raised to the power minus 2. To calculate रेट अमाउंट ऑफ कि कितना कंज्यूम हुआ है. ठीक है, कि द रेट रिएक्शन एंड द अमाउंट ऑफ बी कंज्यूम इन द इंटरवल ऑफ 10 सेकेंड, कि कितना बी कंज्यूम हुआ है 10 सेकेंड में. सो हाउ विल यू राइट दिस बेटा? देखो, सो वी नो, if we write the rate of reaction in terms of B, how will you write beta? Minus 1 by 3, and this is dB by dt. So they are asking calculate the amount of B consumed in 10 seconds, right? So how will you write this? So you can write as dB by dt, ठीक है? This dB by dt comes out to be 3 into rate of, right? And what is rate of reaction? That is 3 into 10 की power minus 2. Because my 10 is raised to the power minus 2 is the rate of reaction. Now they are asking in the interval of 10 seconds. So this dB comes out to be 3 into 10 की power minus 2 into 10. So this values comes out to be 30 into 10 की power minus 2. So 13 10 की power minus 2 and 10 की power minus 2 is the correct answer. So which of the following option beta? That is option B. ऑप्शन जो बी है वो एब्सोल्युटली यहाँ पे क्या है, करेक्ट आंसर है. आंसर बी होगा बेटा, नॉट डी. तो बी इज एब्सोल्युटली करेक्ट. ठीक है एवरीवन? ठीक है. यस सर. गुड. ये क्वेश्चन, ट्राई टू सॉल्व दिस क्वेश्चन, ये कर लोगे आराम से. फॉर द फर्स्ट ऑर्डर रिएक्शन प्रोडक्ट इनिशियल concentration is given after 5 minutes, rate constant. So for the first order, which equation we are using? K is equal to 2.303 t log r naught divided by r. ठीक है. So here we have 2.303. What is t? So they are in a 5 minutes. So this is 5. This is log. What is initial concentration? 0.1. बस सिंपली. So 2.303 divided by 5. So 10 raised to the power minus 3. And this is, एक सेकेंड, इसका हो गया 10 10 10 की पावर 2 आ गया. ठीक है. log 10 raised to the power 2, यानी 2 log 10. So this comes out to be 2.303 into 2 log 10. log 10 value is 1. log 10 का वैल्यू क्या होता है, 1. So this is 2.303 into 2 divided by 5. This is करेक्ट. क्या आएगा बेटा, जल्दी बताओ फटाफट. क्या आ गया? So the values comes out to be 0.9212. 0.9212. तो बी इज द करेक्ट आंसर. ठीक है. सी बोला बेटा, नहीं बी. बी इज द करेक्ट ऑप्शन. ठीक है. सो बी इज एब्सोल्युटली करेक्ट आंसर. आई होप दिस इज क्लियर टू एवरीवन. ठीक है. चलो. सो थैंक यू ऑल फॉर ज्वाइनिंग द क्लास. एंड हमने बहुत सारे क्वेश्चन सॉल्व किए, लॉट्स लॉट्स ऑफ क्वेश्चन. तुम और भी सारे क्वेश्चन सॉल्व कर सकते हो. ठीक है. मैंने थोड़ा सा कॉन्सेप्ट भी बताया एंड ट्राइंग टू सॉल्व क्वेश्चन एज वेल. तुम लोग भी और क्वेश्चन इस चैप्टर से सॉल्व करो. दिस इज वेरी वेरी इंटरेस्टिंग एंड यू नो वन ऑफ द वेरी गुड चैप्टर्स. इफ यू रिमेंबर द फॉर्मूला ना, then you can easily solve question from this chapter. This is going to be very very easy if you learn the formulas and you know to apply the formula in which question. ठीक है, तो दिस इज वेरी इंटरेस्टिंग चैप्टर. नाउ आई एम गोइंग टू लॉन्च अ क्विक पोल. सबको रेटिंग देना फटाफट, पोल का रिप्लाई करना है. ठीक है, चलो. चलो, आई एम लॉन्चिंग द क्लास फीडबैक पोल. सभी फटाफट इसको रिप्लाई करो. ठीक है. यस बेटा, कंप्लीट.